Yeah, hi, good morning everyone. So shall we begin the session? Today's topic is testing plans. Yes, Larry, where are the other students? Okay. So let's start with the testing plans. What are the various plans that is used in the testing to make the test plan as a successful or make the testing as successful for finding the bugs, finding the errors. So philosophy behind the testing is to find the errors. So main logic behind the testing is to find the errors or the bugs, and the test cases are devised with this purpose in the mind. So that means test cases are derived or devised or used with this purpose in the mind. That is how to use or what are the various plan that is used for the testing. A test case is a set of the data that the system will proceed or process as normal input. So that will process as a normal input. That is a test case. However, the data is created with the express intent of determining whether the system will process them correctly or not. So whether the system, whether the data is correctly or whether the data is processed correctly or not. For example, test cases for the inventory handling should include conditions in which the quantities to be withdrawn from inventory exceeds, equal, and are less than the actual quantities on the hand, and each test case is designed with the intent of finding the errors in the way the system will process it. So it will find the errors by which we can find that what are the various input, what are the various output that is going for the test cases. And there are two general plans for testing the software. One is for that code testing, one is a specification testing. So as the name advises, first one is a code testing. That means a code is generated or the code technology or strategy examines the logic of the program, and to follow the testing methods, the analyst develop test cases that result in executing every instruction in the program. That is, every instruction is executing in the program or the module. That is, every path through the program is tested. Each and every path is tested over the code testing, and the path is a specific combination of the condition that is handled by the program. For example, in the accounting system example, one path through the system is to change the account balances. So one of the path that is used to change the account balance and the correct request is submitted, then the proper password, data, and the command enters. That means once the password is correct, then you have to enter the data. That may be a password, that may be a data, that may be a commands. And on the surface, code testing seems to an ideal method for testing the software. On the surface means as an ideal method or as an fruitful method, code testing is one of the good methods for testing the software. However, the rationale that all the software errors can be uncovered by checking every path in a program is faulty. So first of all, even moderate large programs of the size used in the typical business situation, it is very impossible or it is virtually impossible to do the exhaustive testing of this natures. And financial consideration and the time limitation alone will usually prejudicate the executing every path through a program. That is how the paths will be generated and how the system will be generated for the critical path. And if the code testing can be performed in its entirety, it does not guarantee against the software failures, and the testing process or the testing strategy does not indicate whether the code meets a specification or not. Because this testing focus on the coding part. This does not focus on the specification, nor it determines whether all the aspects are even implemented or. And code testing also does not check the range of the data that the program will suffer or that the program will accept, even though when the software fails or software failure occurs in actual usage, it is frequently because users submitted data outside of the expected ranges. So whatever the user data that is expected in the range, that is of the frequently usage because of the expected range. So code testing is done. That means whatever the code that is used or whatever the testing that is used for the coding, that is known as the code testing. Next one is the specification testing. हाथ क्यों हिल रहा है? Next one is the specification testing. Now to perform the specification testing, the analyst determine the specification stating what the program should do. So what is the content of the program, what the program should do, and how it should perform under various conditions. That means what are the various requirements that is gathered, how that requirements will fulfill the requirements of the users, what are the various program, what are the various software that is built by using that program, whether the program, whether the test that is developed, whether the specification that is used or that is performed under various conditions. After this, test cases are developed for each condition or combination of conditions and submitted for the processing. And by examining the results, analysts can determine whether the program performs according to the specified requirements. That is, whether the program performs the specific requirement, whether it is a specific required requirement or no. And this strategy treats the program as if it were a black box testing. Then the analyst does not look into the program to study the code and is not covered about whether every instruction of the path through the program is testing or not. So this testing is very easy, and this strategy is very easy. Treats the program as a black box testing. That means we are going into the structure, we're going into the boundaries of the program that is tested out. And in that sense, specification testing is not complete testing. However, the assumption is that if the program meets the specification, it will not fail. So we generally predict that if the specification is correct, if the requirements are correct, then every phase is also correct. So assumption is that if the program meets the specification, it will not fail. Yes, I agree with your point, Joseph, that even after the specification in the designing part or in any part, the program fails. But generally, it is a trend that if the requirements are gathered correctly and it is processed correctly, then there's no chance that the program will fail. 90% chance is that the program is successful, but 10% is also used for the designing, for the testing, and so on. Neither code nor specification testing is ideal. But if I'm talking about the comparison of the specification and the code testing, so specification testing is more efficient strategy since it focuses on the way software is expected to be used. And it also shows once again how important the specifications developed by the analyst throughout the entire system development process. So anyone, any doubt in the code testing plan and the specification testing? Specification testing, we can say another name is a requirement testing. Now next is managing the testing practices, how we are dealing with the testing or how we can test the test plan, how we can use a test plan, how we can test the software. So regardless of which technology will follow, that may be a code testing, that may be a specification, whatever the testing that is followed. So there are preferred practices to ensure that the testing is useful. And the level of test and the type of test data that is combined with the testing libraries are important aspects of the actual test process. So what are the various level of test and the type of test data that is performed that is combined with the testing libraries. So let's start with the levels of test. So let's begin with the level of the test. Systems are not designed as an entire system, nor they are testing as a single system. The analyst must perform both the unit and the integration testing. It's the responsibility of the analyst that must perform both the testing at the equal level, that is the unit and the integration testing. And the systems are not designed, and systems are used as an entire system, not they are testing as a single systems. And the first one is the unit testing. So in this unit testing, the analyst tests the programs making up a system. For this reason, unit testing is sometimes referred to as a program testing also. And the software units in a system are the modules and the routines that are assembled and integrated to perform a specific function. So whenever we are performing the requirements, whenever there is a specific software unit that is used in a system, that are the modules. So we can divide the, or we are dividing the we have already discussed that we are dividing the main program into the multiple modules, and that modules and the routines are assembled and integrated to perform a specific function. And in a large system, many modules at the different levels are needed. So many modules for different levels are testing, that is known as a unit test. Unit test means dividing or the main program into the modules, and each module is tested. After each module is tested, they are clubbed together, they are mixed together into one module. That whole module is also tested. So unit testing focus first on the modules independently of one another to locate the errors, and this enables the tester to detect the errors in coding and logic that are contained within that module alone. So that is contained in that module alone for the specific. Yes, yes, just wait. So unit testing focus on the modules of one of the two module that is used to locate the error, that is used to detect the errors in a coding and logic that are contained within that module alone. And those resulting from the or from the interaction between the modules are initially avoided. So whatever the result that is taken out for the interaction, that is generally avoided for the unit testing. So what is the unit testing? That means dividing the program into the multiple modules, and that then modules are tested. That is known as the unit testing. For example, when we took, for example, an hotel information system that consists of the modules to handle the reservations, guest check-in and the checkout, restaurant, room service, and the miscellaneous charges. So, if I'm talking about a hospital or the hotel information system, hotel management system, that is a full-fledged system that consists of the modules. What are the various modules? One is for making or for handling the reservations, then guest check-in and check-out, then restaurants, room service, miscellaneous charges, convention charges, account receivable, billing. So these are the various modules, or these are the various, we can say, the parts of the hotel reservation system that is used in the hotel information system. And for each, it provides the ability to enter, change, or retrieve the data and respond to the inquiries or print the report. So each and every module works to enter the data, works to change the data, retrieve the data, and correspond to the inquiries or the print the reports. And for each, it's provide the ability to enter, change, that is done. The test cases needed for unit testing should exercise each condition and the option. For example, test cases are needed to determine how the system handles attempt to check in guests who do and do not have a reservation, that is, who have a reservations and who do not have a reservations, as well as those instances involving changing the name of that on the reservation when the person other than the one listed arrives. So whatever the person, whosoever the person that is you that arrives for the module, that arrives for the test cases. And also needed are test cases for the checkout situations of paying the exact amount of the bill, only one bill of only part of the bill more than the amount shown, and even checking out without any payment at all must be included in the test case. Now, if the module receives or receives input or generate the output, there are test cases that is generated. So there are test cases. So the test cases needed for the unit testing that should exercise each condition and option. For example, test cases needed to determine how the system handles attempt to check guest in. For example, if I develop a test case for handling the system that handles how the guests check in when the guests enter into the hotel, that is known as the check-in. So how the guests check in. What are the test cases that is used for the reservation when the person other than the one listed arrives? And also needed are the test cases for the checkout situations of paying the exact amount of the bill, only part of the bill, and more than the amount shown. Even checking out without any payment at all must be included in a test case. But if the module receives input or generate the output, there are multiple different test cases that are also needed to test the range of the values expected, including both the valid and the invalid data. Now, so that means we are including the boundaries of the data values also. Yes, for example, suppose I receives the input as a 75, output as a 85. So that 75 number, not starting with a 76, that 75 number is also included and the 85 number is also included. So test cases are needed to test the range of the values expected, including both the valid and the invalid data. What will happen in the hotel checkout example if the guest wishes to make a payment of 1 lakh for an upcoming convention? Are the payment and the printing module designed to handle this amount? Testing for this question quickly detects existing errors. So if the module is designed to perform the iterations for specific processes contained within a loop, it is advisable to execute each boundary condition, that is zero iteration, one iteration throughout the loop, and the maximum number of iterations throughout the loop. So how many iterations is follows? It is followed for the zero iteration, one iteration, and how many maximum number of iteration that is used throughout the loop. Of course, it is always important to examine the result of the testing, but special attention should be given to these conditions, and the analysts too often make the mistake of assuming that a case of zero iteration will automatically be handled properly. And unit testing can also be performed from the bottom up, starting with the smallest and the lowest level module. So it starts from the smallest and the lower level module and proceeding one at a time. And for each module in a bottom up testing, a short programs, that is a small program, modular programs are carried out, are taken out, provides the data, take the input, so that the module is asked to perform the way it will when embedded within the large systems. And when the bottom level modules are tested, attention turns to those on the next level than the lower level modules. That means attention is given to the lower level modules for the previous data. In the same way, unit testing is also used with the top-down approach that begins with the upper level modules. That is a detailed activity that is performed in the low level modules, low level routines, that is also provided with the stubs. Now question arises, what is a stub? This is also a module shell that will be used by the upper level module and that when reached properly will. So next level that is where we were, that is on the stub. So stub is a module that is a small module that is used or that can be called by the upper level modules, and when reached properly will return a message to the calling modules that indicate that the proper interaction occurs. And the no attempt is made to verify the correctness of the low level modules. So if I make the summary of the unit testing, that means we are dividing the main program into the sub part that are known as a module, and each module is tested from the user ends as well as the receiver ends. After each module is testing, then these modules are clubbed together, reassembled together into the one module, into the one program. That whole program is also testing, but that is a different issue, that is a different testing. But when we talk about the unit testing, that is only the modules that is tested together, that is tested separately. Next one is a integration testing. So it does not test the software as per the, yeah, just wait, Joseph. So integration testing tests the software rather than the integration of each module in the system. It also tests to find the discrepancies between the system and its original objective, current specifications, and the system documentation. The primary concern or the primary main motto is the compatibility of the individual modules. And the analysts are also trying to find the areas where modules have been designed with different specifications for data length, type, and the data element name. So whatever the data type, whatever the data element name that is testing out, that is known as the integration testing. That means multiple modules are linked together, integrated together, clubbed together for the customer identification number. For example, that is used for the custom identification number to be numeric field, while other module expect to be the corrected data items. The system itself may not report or may not report this as an error, but the output may show the unexpected error. And if the record created and stored in one module using the identification number as a numeric field, it is later stored on the retrieval with the expectations that it will be a character field. Then that will be recognized and the message will be displayed that the requested record not found. And this integration testing must also specify that the file sizes are adequate and that indicate or that indices have been built properly on the file sizes. Sorting and re-indexing procedures also assumed to be present in the low-level module that must be testing at the disk system level to see whether they are in fact they exist or not and achieve the results module what we expect. Next one is special system test. There are some also tests. There are six, we can say, the special test that is used in the categories of the special system test. Now, first one is a peak load testing. These are there are critical times in many systems, particularly online system. For example, when you talk about the banking system, that is an online system. Every transaction is online. Analyst wants to know what will happen in if all the tellers signs on their terminals at the same time at the initial time at the local time that is used for this one. So will the system handles each and every incident at the same time? That means that is an online system, that is a real-time system. So whether each and every transaction, whether each and every instruction must be tested, will be handled at once and be confused if that locks up and must be restarted, or will the terminal address be lost. So it depends on the scenario. What is the scenario? If more than one terminal tellers are using at the same time, the only sure way to find out is to test for it. The same conditions can arise when the tellers sign out during lunch periods at the end or at the end of the day. So testing is looking at the real situations. That is a peak load testing, where is a peak time that testing will be performed for the peak time, that is known as a peak load testing. Next one is a storage testing. So analysts also specify a capacity for the system when it is designed and constructed, and capacities are measured in terms of a number of the records that a disk will handle or a file that contain. These capacities are linked to disk spaces and the size of the indices, record keys, and so on. And if the documentation for a new system to be run on a microcomputer, so the microcomputer claim that the disk file can store up to 10,000 records, each 393 bytes long, and the claim must be verified before the implementation for the 1,000 or 10,000 records. And storage testing often requires entering data until the capacity is performed or until the capacity is reached. Comparing the actual and the claimed capacity will verify the accuracy of the documentation. What is the accurate information that is stored in the storage testing, or how we will test the storage. And users also find out too late that the claims made during the installation are not due, that there is no or not enough storage capacity for the transactions and the master record file that is used with the installations. Then next one is the performance type or performance time testing. So now, as the name advises, this testing is performed on a performance time. So when the analysts are developing a design, their concern are more on the reports, input files, and processing sequences than on the performance time. Although this change, yes, this also changes with the experience, and during the simple unit and the integration testing, a relatively small set of data are used to find out the errors or cause the failures. Therefore, the users frequently find out the how slow or fast the response time of the system is only after it has been installed and loaded up with the data. That may be too late. Systems are rarely too fast for users. That is a performance time testing. And this is conducted prior to the implementation, not after the implementation. This is prior to the implementation that is conducted over to the or determine how long it takes to receive a response to an inquiry, makes up a backup copy of the file, or sends a transmission and receives a response. It also includes test run to time indexing or resorting of the large files of the size that is included in the typical run or that is included to prepare a report. So a system that runs well with only a handful of the test transactions can be unacceptably slow when there is a full load. So when there is a full load, that system will become slow. And the time to know about this is to prior to the implementation, when the adjustment can be made more easily. And once the files are fully loaded and the user is relying on the system for daily activities, it is difficult to pull it back. And being large scale changes, the users need the system, and the analyst will not want to take the risk of the live data, because live data is very crucial. That must be updated on the time, that must be updated on the way. They are very crucial, and the analyst will not want to take the risk of the loss of the data. Next one is a recovery testing. Recovery testing. So whatever the recovers, or whatever the recoverable material that is recovered from the magnetic tape, magnetic disk, that are testing out whether that data will be carried out, or whether that data will be useful for the analyst for making the next operations, for rebuild the system or rearrange the system. So analyst must always assume that the system will fail and the data will be changed or lost. Even though plans and procedures are written to cover these situations, they also must be tested. And by creating a failure or data lost event where the users are forced to reload and recover from a backup copy, the analyst can readily determine whether the recovery procedures are adequate or not. The best design plans are adjusted or augmented after this test. So after this test, whatever the best design that is recovered, that is used for the recovery procedures. Next one is a procedure testing. That means whether that procedure that will follow for the testing is correct or not. That is a procedure testing. That is also used with the documentation and the run manuals that tells a user